So let's go to our first problem. How about it? Problem of the day. It says take the binomial 3x plus 2 and raise it to the, the third power, and simplify your final answer. That really kind of took my breath away, all right? It may take some of your breaths away there. I don't know. Let's see. Take the binomial 3x plus 2 and we're going to raise that to the third power. So let's take a look at this one. Let's see what's going to happen. First of all, we link those parentheses because it's an entity. Now, it's an expression. There are two terms in there. That's why we call it a binomial. And it's got a plus in between it. But we're going to start with that little expression, 3x plus 2. And the idea is we're going to take that to the third power. All right? Now, like some of my students, they go like, oh, yeah, it's easy. I'm going to say 3x to the third power, and then I'm going to put 2 to the third power, and I'll be done. I wish it were that easy. I really, really do, because it would be a lot easier not to have to worry about teaching kind of things like this. But this is basically for you Algebra 2 students, and actually some Algebra 1 students, you'll see this kind of problem. We take it step by step, all right? Because really what this says to us is we're going to take 3x plus 2 times 3x plus 2 times another 3x plus 2. So this one's pretty, I think this is a pretty adventurous problem of the day, all right? What a great way to finish off the season with one's a little bit tougher. But no, don't leave us and don't give up on it, all right? That's why we have a few challenges. Sometimes we have easier ones and such, but this one I think will work some of you pretty well. Now, again, let me tell you what it is not. And look at that, I'm going to put a not equals to. It is not equal to 3x times 3x times 3x, which would be something like 27x to the third. And some of you will even forget about the 27. You would just write, oh, it's 3x to the third. That's easy. It's 3x parenthesis to the third, which would give us this value. And then others of you would say, oh, let's just add 2 to the third on the end, and we're done. Well, you know, there's a lot of stuff going on in between. A lot of things going on here. So let's take this thing one step at a time. It's the best way to do it. By the way, no, 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 do not do it this way, all right? Do not use that and say, I'm done. That's why I've got a big not equals right there, like Ghostbusters, not equal busters, whatever. Don't do that. So let's see how we are going to actually do it. We're going to use the infamous FOIL, or multiplying two binomials together. And we'll pick up this last binomial here in just a second, all right? So this is going to probably take a lot of space, so get your pencils out and work this thing with me at home. We're going to have, first of all, like I said, we're going to talk about the FOIL, so to speak. That about first, outer, inner, last. So we'll take our 3x times our 3x. That's going to give me 9x squared. Well, that sounds interesting. Go to the outer term. The outer, that would be the 3x on the front end and the 2x on the very back end here. Forget about this little guy right here. We'll get him later, all right? Don't worry about it. We're just going to take 2 of them at a time. That's the best way to do it. Divide and conquer this problem. Take it bit by bit. All right, I got 6x out there, right? 2 times 3 gives us 6x. Go to the inner side. I've got 2 times 3. Oh, that's the same thing, isn't it? So it's still 6x. So 6x and 6x is going to add up to 12x. Let's save a little bit of space there, all right? It's got 12x in the middle. And last, let me mark that inner. And now we're going to take our last. That's the 2 times 2. Everybody knows 2 times 2 is 4, right? And we got that. So now I'm going to put that, because now we have a trinomial created, but we've still got to take care of this last 3x plus 2. Now, this one is going to stretch a little bit. It's going to stretch a little bit. You say, well, Ernie, we would have been good, and we would have been good. I know. You guys out there in Mathline are always good. It would have been good. It would have been great if we had had just, you know, a couple of these things, but we've got 3, a trinomial to multiply by a binomial. So that means to me we've got to have 6 things we're going to multiply, 6 little products that we're going to try to add together. And you say, wow, this problem of the day is taking a long time. This problem of the day is taking a long time. You repeat after me, but let's work through it and see what happens. First of all, we're going to take everything in this big parenthesis times the 3x. All right, so we're going to go along here, and we're going to take 9x squared times 3x. I'm going to draw the line, arrows here. We're going to hit it, and we're going to go here, and we're going to finally get there. All right, So it's a triple whammy here. Distributive property. Oh my goodness, on fire today. So let's look at this. We're going to get 3x times 9x squared. That's what everybody said. I knew it was going to have a 27x squared. No, not x squared, but what? X to the third now. All right, so we'll put that together. All right. Now let's go to our next little business here. We got 12x times 3x. That gives us 36x squared. Unfortunately, we didn't get an x squared at all up here, did we? It's got to have some x squareds going on. That's true. So now let's do one more thing here. Let's take that 4 times the 3x, and that gives us 12x. So all I did, I multiplied by 3 and pumped up the exponents by 1 power. 1 notch, okay? Because we're multiplying by 3x. So you triple your numbers, and you bump up the exponent by 1. That's what we did the first part. Now, the next part, I've gotten a lot of jam up here with all these letters, numbers, and such here. We're going to take this parenthesis, this trinomial, and multiply it times 2. That means we're going to double everything in here, not the exponents, but every coefficient. All right? So we're going to take 9x squared times the 2. It's going to give us 18x squared. Now, folks, I call this kind of a hybrid method because we started working horizontally, and we're going to still work horizontally. But we're going to stack these things up vertically. So it's called hybrid because we're going to use a little bit of horizontal, a little bit of vertical movement here. So we're going to take our 9x squared times that 2, and it's 18x squared. And look where I'm going to line it up. I'm going to put it under 36x squared because those are like terms. They're going to be able to add together. Yesterday, Rachel called in from down in Franklin County, and she was asking me about these like terms. How can we do this? Well, here's a great example. I hope she's watching today, and she gets to see how we line these things up. Now, my next little moment is I've got 12x, and I'm going to take it times this 2. Remember, we're now working with the 2. So 12x times 2 is going to give us, looks like 24x. I like that. And you've been waiting for the 8, right? Well, you got it right there. 4 times 2, that's going to give us 8. And at this point, what we're going to do, we've got our, remember I said we're going to have 6 multiplications? Well, there's 1, 2, 3, 4, 5, 6. We're going to add these together and see what happens. And we're going to get 27x cubed. That was pretty much what we thought, okay? But what's going on in the middle? We've got a lot of positive things going on here. Actually, we've got 54 of them. 54x squared is going on here. So we're going to add the 36 and the 18. That gives us 54. Bring the x squared down for the ride because you're just talking about like apples or oranges. They just come down. They don't change. And these are also like terms. 12 and 24. You can add the, in fact, you can look at those and add them up. They're going to give us, looks like 36x. And last but not least, we have 8. Now, of course, some of you are going like, Ernie, is that what you mean by simplify? That's what I mean by simplify. In other words, we went from 6 little terms down to 4. And some of you are going, boy, I wish I'd gone to that. I do too a lot of times, but unfortunately, the mathematics would not have panned out.